10 seconds ago from the community. So, once Zebulon and Demian delegates finish with the OCaml release, they hand it over to us to integrate into a platform. So the slides here, as I said, have been received a vast number of contributions from a number of people. So I'm just delivering the work, but I'd like to thank all of the people who actually did a lot of hard work over the last year to make this possible. So just to give you a recap of what the platform is, when I stood here last year, I described what the essence of building an OCaml platform is. It's tooling that works together in a consistent way to work beyond just the core compiler, but also into full development lifecycle. And also we need quantitative metrics to judge if we're doing a good job or not. Are we helping in terms of builds and tests and documentation and so on? And also use this platform to help us keep agile. If we're going to keep evolving OCaml to add a lot of the new features that Zebulon just described, how can we judge the impact of these changes and evaluate them in a quantitative way? And the ultimate goal here is to build a sustainable open source community. So we want to be able to continue to develop OCaml code for the next decade and not just get burnt out by heroic release managers or individual contributors all trying to build these systems and spending a lot of time. We want everyone to contribute to the health of the platform and also to build automatic tools where possible to simplify this. So just out of curiosity, how many people here use the OPAM package manager? Oh, it's amazing few. I was going to leave if no one had answered. But this was the big effort in 2013 was to release the first iteration of this package manager, and it was just a lot of effort in 2013 just to to get the basics in place, and we attracted a lot of interesting initial effort, and we migrated that to the community. In 2014, we saw some very significant releases. So we've been trying to keep the releases controlled where possible to reduce the burden on upstream packaging. We saw, first of all, OPAM 1.1, the triple one, which saw most significantly some very high quality contributions from Roberto Di Cosmo, he's over there, who gave us a better interface to the Mancusi tools to have a very stable solver. And 1.1.1 is now present in a lot of upstream distributions like Ubuntu and Debian and so on. So once that was done, we shifted into developing the new 1.2, which I'll describe today. But in the meanwhile, we just released a point release just to make it easier to integrate it into upstream distributions. And also the release manager shifted to Louis Gaspard from OCaml Pro, relieving Thomas Gazinier of the burden of dealing with all the bug fixes. And below, we have seen an increasing number of pull requests and issues and reports from the community, and we're just about managing to keep up with the load there as well. But the most significant part of OPAM 1.2 is that it's the platform release. And so I thought I would describe some of the thinking that's gone into the new features, first of all, by giving you an overview of what we're doing. So we really wanted to simplify the workflow where possible for developing OCaml code. We should not expect people that use the platform to understand all of the little details of our tooling. We just wanted to kind of guide you to the next steps where possible. The first thing was to get rid of Boolean formulae and error messages. This is a small but significant thing, because if the first experience you have with OCaml is some massive traceback from a SAT solver, then that's not ideal. So we put quite a lot of work into interfacing with the external tools and actually explaining the results. And this is actually even better than Debian's solutions in some cases. So we're hoping to upstream back some of these changes into the wider uses of these external solvers. After that, we also just increased the query interface. So as the OPAM package database grew, people wanted to do more and more interesting queries. So now, for example, say if I'm building something like an HTTP library that has more and more users, we can query the reverse dependencies recursively. So I can see exactly what the impact of me changing a core library is and actually do local recompilations to figure out what's going on. So just the ability to query and understand more of the OPAM interface is very, very useful and important. And then also, these are all little features that help improve our day-to-day use of OCaml, is that we can clone the source code for any OPAM package just with one command. So I can say, oh, I want to use Caml on the web, give me the source code, and it'll automatically download the archive and be ready for use. Now remember that OPAM also supports a distributed workflow, so Git and Mercurial and so on, and this automatically figures out where it would get the source code from. For example, it might be doing a Git clone, and it will just take care of everything and make sure it works. Similarly, all of the metadata that goes into this, you can just cut and paste that. Although we're modular in our programming, we're not that modular in our packaging, so cutting and pasting OPAM descriptions is quite common. And so in this case, you can just show the raw information and off you go. So in terms of health, we just keep a track of all of the graphs in our of all the number of packages submitted, and we've been doing pretty well actually. So last year there wasn't quite enough data to figure out what the overall trends were, but we've generally seen a steady growth in the number of total number of packages in the ecosystem. So this is a nice kind of linear curve. The little bump there was due to I think the Mirage OS release where we just imported a ton of libraries, but generally things are going pretty well, and the fact that it's going up just means that people are not just putting packages in, they're maintaining their packages, which is obviously important with new releases and so on. But you know, things start looking a little bit less exciting when you start looking at the number of contributors. So I was hoping the number of contributors would increase, but while it's seen steady growth and we're very happy with it, it's not growing as fast as, for example, the total number of packages. This means that a few people are contributing a lot of packages to the ecosystem. And then when you look at the unique number of packages, this is the set of packages with every version counted only once. You can see there's starting to be a slowdown in the input to the OCaml community, just in terms of have we leveled out in terms of getting all of the existing packages that were not in OPAM, and they've all been put in OPAM now, and so are we just starting to slow down. So we took a long, hard look at this when working on OPAM 1.2, and we decided that we needed a completely new workflow that was just much easier for new people to use, so that we can hit the next step of people contributing and getting involved without being heavily into OCaml. We want to grab the next stage of users. So let me just show you this new workflow to show you how simple it is. So Louis Gesbert from OCaml just gave me a new package called OCP Reloc, which is to build a relocatable compiler, which will make it more compatible with zero install that we just saw. And so in this case, we'll just CD to the reloc package, and we'll just pin this and give it a name called OCP Reloc. If you did this with OPAM 1.1, it would just give you an error. Now what happens is that it just detects the fact that it doesn't exist, and it will just create a new package. So just the act of pinning something that doesn't exist before gives you the opportunity to create metadata and just to get on with package construction. And it's pinned, and it's all part of your OPAM universe now. And once that's done, just like when you're editing pseudo files, for example, an editor is brought up with a sensible base template. So you don't have to cut and paste existing stuff. You just get the current best of breed OPAM template to fill in with all of your metadata. So you just can get on with the job of filling it in and then go back to editing your package. We're just kind of trying to stay in the background as much as possible. Now, something to notice, I'll come back to this later on in the talk, is that we have new metadata fields in OPAM 1.2, particularly for bug reports, for home pages, and also for development repositories as well. So this metadata is increasing the amount of cool stuff we can do with OPAM. And then the other thing you'll notice is that we also have predicates for build and test only dependencies. So if you've recompiled a CAML find, and you suddenly find that core and 10,000 other packages are recompiling, this will no longer be the case when build-only dependencies or test-only dependencies do not force a universal recompilation. So a general improvement in metadata through this and the adoption on the basis of new packages. And if you've ever edited a pseudo file, it's a rather baroque DSL. And similarly, OPAM can be unfamiliar to people who are new. So anytime there's an error, rather than waiting for you to update, as soon as you exit the editor, it will just try to parse it, give you location information that can be parsed by Emacs or VI, and you can just go back and retry editing until you get something that's correct. So we're just trying to close a loop on errors. And then when you're done pinning, any dependent packages automatically get reconciled and updated. So the idea here is that I've created a new package, I've declared some dependencies, and if my universe of dependencies changes, then it will just figure things out and take care of business. So it will always make sure you have a consistent environment to work with. So in this workflow, we've now been able to create a new package and just get on with working. Now, when it comes to sharing this, things also get significantly easier. So we've just created a new OPAM file, and we can just add that into our repository and source version control it just as we version control any other configuration information for the package. And then other developers, if I want to share this package on GitHub, for example, or through other version control mechanisms, can simply clone my source repository and pin it directly. Or they can even OPAM pin git://. And OPAM detects the existence of the OPAM file and just make sure that all of the metadata is reconciled. So in general, we're just sprinkling OPAM metadata around packages and auto-detecting its presence, so that just this the action of putting it there will give OPAM the necessary hints to get on with installing dependencies and moving out of the way. Similarly, we can also, once you put this metadata in, if I want to bug fix someone else's code, I can simply directly clone it. I can say OPAM source OMD ---- pin. This will download the source of OMD, pin it locally, and let me patch it, and then take care of all of my local dependencies. So with one command, I can now just modify an existing package, do my bug fixes or feature improvements, locally test it, and then share it back. With the new metadata for dev repo, we can even pin it to the development Git version as well. So you can just grab any kind of remotes, shift your universe entirely to a development bleeding edge version, and get on with things. So these are all really cool features, and we were struggling when it came to this talk because we've done all of this work, but we need to release an OCaml Platform 1.0. That's what we wrote in our abstract, and that's what we have to do. But then what we have here is this what we're actually spending our time on is improving the tool that we release and the tool that we want to maintain. So what's actually really happening is that rather than trying to construct a separate OCaml platform, we realized we're really building a set of tools around OPAM. We really have just released this one thing that's an interface to the wider package universe, and we want to build a set of tools around OPAM that provide a modular workflow. By modular, I mean we're not going to force people to use any one component, and we're providing the infrastructure to develop, publish, and maintain OCaml source code around this engine that is proving to be successful and is taking off. And also to work online and offline, so it can work both on the internet, but also in corporate environments. For example, such as Citrix and other companies that use OPAM, they want to work inside their corporate firewall. So nothing in this is forcing people to go online. And so when you think of the OPAM platform this way, it's actually pretty good because we can realign all of our work around the tool we've already released. You can also have a backronym. The OPAM could also be the OCaml Platform, if you think very hard. That's right. But it gives us the ability to actually start communicating. So the first thing we did when doing all of this work was just internally synchronize with a new blog at opam.ocaml.org, and we really want articles from people using OPAM in interesting ways, just to start sharing tips and tricks. And really, it's just a matter of communicating what we do with OPAM. So we restructured OPAM 1.2 fairly fundamentally to support this modular approach to programming. So OPAM is normally just a command line tool, but it's just a thin layer of command line parsing on top of an OCaml library called OPAMlib. And then we have the data, which is the OPAM repository, which is the online repository of all the information. And the first thing we did was we just used OPAMlib to build a little tool called OPAM Publish. And what OPAM Publish does, I apologize for the small font there, we had a last minute screenshot that's very long, thank you, Thomas. The single-step publication just requires, well, it requires two steps actually. The first step is called OPAM Publish Prepare, where you simply just say OPAM Publish Prepare, give it the name and the version of the package and the source code, and it automatically downloads and creates a metadata template based on the OPAM metadata you constructed, and then you submit, which sends it to GitHub. But of course, you can build another submission for any other publishing platform that is not GitHub. But we've just automated the entire process, so you don't need to do a checkout and a git clone and WordPress, and all of that is taken care of behind the scenes. So once that's done, the second bit of restructuring is that we're now starting to add more and more tools around OPAM to build this platform. And the next thing we did was we took OPAM libs and we built a new library called OPAM units. And what that does is that it decomposes any OPAM library into the constituent fidelib components that form it. And so fidelib is a package manager for all of the individual components. And OPAM units gives us a nice functional interface just to fold and iterate over fidelib packages. And so we did a massive bulk build of OPAM using automatic build systems, and we've committed all of the fidelib files through mechanized builds, and we keep those in sync automatically as part of our housekeeping. And then what that does is that it lets OPAM doc output a complete universe of documentation into the OPAM repository. So the OPAM documentation, our goal, I actually talked about this last year, was to have unified documentation across packages that handle cross-referencing just automatically, so you don't have to worry about it. OCaml Doc's been a stalwart tool for over a decade, but it is time to have links on the internet. So, but it's very hard to do. So while I was quite flippant last year, it's been a hard year of engineering to replace OCaml Docs. I have a lot of respect for the tool and the job it's done for the last decade. The reason it's hard is because not all packages can be installed simultaneously. There's fundamental constraints in our universe. And also resolving module inclusion statically leads to just a combinatorial explosion of type substitutions and so on and so forth. And it needs to integrate with the whole toolchain. So what we've done is, well, firstly, is that I have these little URLs that tell you how to get involved. Everything can just be expressed as an OPAM remote of development packages. And here we have a development remote for the platform. So if you're interested in switching into platform mode even before it's released, you can grab the bleeding edge and just suddenly switch into our world. And our approach is quite simple. So in OCaml 401 and 402, we've been increasingly putting out the type abstract syntax tree into the distribution. So that's all put in place, and we generally propagate through extension points and external tools all of the documentation information into the system. And then we just need to resolve these OCaml names from once we take these typed ASTs into linkable URIs. And so just to give you a preview, you can go to ocaml.github.io/platform dev. It features OCaml.org integration, so it has the same look and feel. It includes notion of finelib packages and also module docs. We haven't quite finished styling yet, so but it also does feature cross-references between packages. If I can convince this thing to switch, I just wanted to give you, well, a sense of what this is. Oops, no, this is not this is what David Dolges was just showing. No, so what we have here is, it's a slightly different styling because it's a small resolution, but we have our URI library. You can see all of the versions of URI are exposed. You can see all of the metadata around it. I was the original author. Unfortunately, then David Sheets came along and rewrote my library, so he took maintainership from me. So this OPAM history just gives us also the metadata diffs as well. We don't have much metadata now, but it figures out what's happening. Rudy Gerber joined the project, very grateful to him for his patches, and so on and so forth. So it does kind of give us the ability to motivate people to have metadata just because we have a nice human readable diff. And then afterwards you have all of the linkable metadata up here as well. So URI doesn't have many dependencies, but you can see, for example, it's cross-referenced to the sexlib library, and then the sexlib library has all of the parsing information and so on. So I encourage you to go to the website there and just browse it and see what's going on. And David Sheets and Leo White, who's doing a tutorial right now, have been working very hard on this. So now's a great time to give them feedback. So the current state is we have a working prototype, but it's a working prototype with a lot of pieces pulled together as part of this remote. And our timeline is that in September, we're very, very close to having a workable release for OCaml.org. We're going to put that live. And then in November, we're going to issue an OPAM switch that's more supported. The key reason we did an OPAM switch is that this actually modified the OCaml compiler to have a doc switch. So we need to run that past the development team, make sure it's the patch is sane, and also just work through various design issues. It came up on the development list, but too late for 402. It came up the day before feature freeze, which is not a great time to bring up new features. And the other thing that we're doing is that we're adding support for building custom websites. So that James Reed, who published Core, and Async Citrix, who published Zen API, Mirage, which is an operating system that I run, all want to build custom websites around the same tooling to publish their universe of remotes. And this should just work from the same tools. And the reason for that is that this growing set of modular libraries is that we've had OPAM doc, and that feeds back into this tool called OPAM to Web, which uses libraries that are increasingly factored out. So anyone can grab these, build their own HTML styling, and just deploy them all. So we really have made the whole system very, very modular, and with good support for data sources, libraries, and just running normal OCaml code. And all of our outreach stuff, like the vlogs and so on, are just from Git repositories. So we're going to blog about those in the next week. We've started blogging for the last 2 weeks. So this really means that you can just write a bit of OCaml code to start participating in the community and make things happen. Now, there's 2 talks here. They're using an interactive compiler written in JavaScript. So this OCaml.js tool just works. You just take a bunch of OPAM remotes as described, you type in make, and then before you know it, if you have an OPAM switch describing your compiler, you can just publish a pure JavaScript version of your compiler that shows the experimental features. So we have better error messages. I believe there's a talk coming up soon, and also Leo White's modular implicits are all just published on Andy Ray's website to just work. So this is a fantastic way of sharing experimental compiler patches, and crashing in JavaScript is less painful than crashing in a compiler. You do occasionally crash in the real world. So one of the interesting, Mark Schimmel got this working about 20 minutes ago, I believe. And so it's a good example of using OPAM to test very experimental patches. In his case, he's got sufficient GDB output now that you can debug the OCaml compiler with complete type reconstruction and call function calls from native code that are OCaml function calls. So, and so if you want to test a patch like this, then you can just put this as an OPAM switch, do bulk builds, and figure out exactly what's going on. So it's very, very nice to be able to test the impact of some of this. So I just wanted to emphasize, it's really a polish. It's something that's often ignored, but we're spending a lot of time just making it easier to package and install. It seems so minor, but it's just vital for adoption of these systems. And we have binary releases on a number of platforms and rewriting documentation. So please do give us feedback about anything to do with what you think is unclear and so on, or better still, just submit a patch on the various GitHub things. Damien Dolly-Guess has been submitting a lot of pull requests, fixing stuff during an OCaml release because he tries to build the whole of OPAM. We're making that easier by supporting containers and virtualization to build the entire OPAM repository mechanically from one command. This uses isolated Linux containers, but also Zen to provide very strong isolation. And parallel builds are tracked with all of the logs tracked in GitHub. So I'm running out of time. So I just wanted to say we've done all these bulk builds, we've done a ton of stuff. One more feature that came up last year, and I was very reluctant to commit to it last year. But Thomas has been building, along with Daniel Busley, something called assemblage. And builds in OCaml are just very complicated right now. And we've had a number of tools to kind of show us the way. OS being the most prominent. And we just wanted an EDSL that's a nice simple EDSL to describe OCaml projects. And it's a declarative approach that just says, just using OCaml as a host language, you can just declare a project as a set of libraries and binaries that are composed of compilation units. And crucially, not have a concrete syntax. So instead of OSS, which provides a concrete syntax and generates code, we just build fairly simple tools. And then we build more tools that introspect this data structure we've built as a project author and generate build rules that are separate, for example, for makefiles, for Jenga, for OMake, or whatever build system you're using. So this is really a project description mechanism that is so lightweight that it integrates easily with OPAM and other tools and starts untangling the Findlib, Oasis, OCaml build dependencies that have crept into pretty much every project out there at the moment. This is extremely alpha. It's so alpha that every slide has the word alpha on it. So it's something we're developing actively, and we're looking for feedback and so on, but it's not fully supported. And I just wanted to give you a quick sense of what it looks like. It's just an OCaml DSL. You can describe packages and so on, compilation units, and it fully supports all of the nice editor tab completion and so on. And Thomas Kesner is leading this effort at the moment. And it does work well enough for several people to be using it, but we're all prepared to rewrite our build descriptions because it might change at any time. But if you have a burning need for a simple build system, and you can find Thomas, I highly recommend having a chat and getting a demo of assemblage because we're using it today. We want to pass the Daniel Busley test, which is he wants to replace all of his nice little standalone libraries with this workflow, which is a nice dependency-free workflow for many things. And also do a beta release by the end of September. So in conclusion, I presented slightly over time an ongoing effort to build a modular set of tools, libraries, and data that are all written in OCaml, of course, but give us nice, easy ways to write functions that map over a global library source code in an effective way. And OPAM provides the workflow interface to this platform. Instead of a single big shot release, we've decided to switch this ongoing release model where we're always working. We're using our own tools to expose our development repositories to the outside world. And we're going to start being more active in the platform list, which was started a few years ago, but we never quite knew what it was for. But now it's clear that it really is the mailing list to discuss this universe of tools that have been forming from the community, some built by my group in the OCaml Lab, some built by OCaml Pro, but a lot of them just built from contributions from external sources, for example, Andy Ray's code, and the extremely exciting search API that Jun just described to us as well. We will really want to take all of these and integrate them into one conceptual framework. So thank you very much for listening, and if there's any questions.
We have time for lots of questions over the lunch. But for now, if there's one, two quick questions to the microphone, please.
I was just wondering, have you got anything to help with ARM cross-compilation, for example?
Well, I think you have to tell me the one for that one. Well, there are two problems. I actually really want to support ARM compilation to do. So right now we use QEMU ARM to do our bulk builds in ARM. What we do need though is to have better support for the host toolchain being separate from the target. And then we need to fix all the build systems to be aware of this difference as well. So tools like assemblage and so on can support that. So we have the manual steps to support cross-compilation through an OPAM switch. Jerome Volume has created an Android switch, and some chaps in Seattle have created an iOS switch, for example. What we don't have is the global build glue to pull it all together, which motivates our assemblage, because we really want a simple build system that we can convince the community to adopt over the next few years. and this will give us the ability to control build rules in a fine-grained fashion from OPAM, therefore supporting cross-compilation. So not yet, but it's definitely on the radar. And this will also help with Windows, which is almost certainly going to be some way.
Not mine.
Thank you.
So part of the promise of a platform is the idea of, in some sense, artificial stability. Right? The idea of minting a certain part of the world and saying, here's our release of this collection of less libraries, and you don't have to be exposed to the bleeding edge of all the things that are changing as people are releasing minor versions. Well, you didn't talk much about that. I'm wondering if you could say more about what the vision is.
Absolutely. So one thing I'm very resistant to is the notion that we as the developers of the platform define the set of less libraries. That has got to be something that emerges from the wider community. So what the platform does is to support anyone who wants to deploy one of these as a supported set. So for example, Core and async from Jane Street, when using these tools, can build a OPAM repository that's been tested and consistent using the same infrastructure we use for OCaml.org in order to release that as a tested platform. Similarly, a university using LWT, for example, would just check that everything is JS OCaml compatible, for example. So whatever restrictions and specializations you put in the platform will form the long-term support criteria that will go into supporting that. So it is true that one thing we do need to do is we do need, I think, to provide one set of standard libraries for the bigger community to adopt. It's not clear to me what the answer to that one is yet. So we're focusing very much on getting the base tooling in place, and I very much hope that we can create a conversation or a tussle around competing implementations, and so people can start agreeing on migrating them to one source. The problem is, I think I talked about this last year, is that no one standard library is a clear winner. So Core and async are just large with lots of dependencies. This has been addressed by module aliases in 402. LWT is widely adopted, but it doesn't integrate very well with other libraries. It doesn't define its own namespace. Batteries is also popular, but it's a community effort. It's not clear what its long-term future is. So all of these questions still have to be answered, and that's something that we should spend more time on. But we're very, very keen to get our tooling base absolutely solid before committing to any kind of support of that nature.
Right. I guess you're kind of putting together two issues, which I'm wondering if you can start. One is picking what the standard libraries are you want to encourage people to use, and the other is just providing a mechanism for any set of libraries kind of picking a consistent set and saying, here's a good starting point. You can use here and we'll keep it stable for 6 months.
Yeah.
Which it seems like you might want to be able to do separate from publishing your own remote, right? You might want to have the notion of stable sets that people could, in some sense, have integrated with anyone that could be used.
That's right. So my hope, for example, is that commercial entities such as the OCaml Pro, to be clear, I have no formal connection with the OCaml Pro, could in fact provide such commercially supported. Now my observation, though, is from talking to the industrial users, is that each one has a domain-specific use. So Let's See, for example, is very Windows-centric, so presumably their package set would also support Windows. Citrix needs very long-term support because Zen survives for a very, very long time. And so they want ancient packages with security updates. And so each of these, there's no one default set that makes sense. And we have to be very clear, we've learned it from the Haskell community. So their attempt to do a Haskell platform burnt them out because there's a few people contributing a large package set and trying to maintain this massive growth that they've seen recently. And the platform just started getting delayed, and a few people are trying to maintain and stop cabal dependency hell. We don't want to get in that situation. I think we need to learn from the past and try to stick to our strengths of domain-specific libraries where possible. Now, but I really do hope that we do have to start having an opinion about standard libraries. I've used them all. I have no particularly strong opinion right now. They all have downsides, but they're all being worked on. We've seen this particularly, it is encouraging to see the core and async features all of the blockers for that being removed. Similarly with LWT, the addition of multi-core OCaml, for example, presented this morning is helpful. So I very much hope to stand here next year, if my talk is accepted, and to provide a more positive view on this. But I very much hope, for example, Gabriel is behind you, supporting who's the maintainer of batteries. We all need to get together and have a forum to talk about this, and we're very happy to host such a forum at OCaml Labs in Cambridge University.
Okay, last question.
You talked a bit about each package having its own OPAM metadata in the GitHub repository. But right now there is something which is quite nice about this thing called OPAM repository where we write the data, which is that if I do something stupid in my metadata, there is this box named AVSM, I think, that will tell me what's wrong about it.
So flesh and blood.
So what's your, how do you think about having the metadata more well belonged, close to the source file, but then still having these checking tools and quality assurance?
Yeah, so this is only for bleeding edge. So a very common problem is that you're developing a library, you add a new dependency, and the stable OPAM metadata has no idea of the new dependency, so your universe breaks. It's very, very common. So by having the bleeding edge version, the development version, in the development remote, we can simply take snapshots of that metadata into the global OPAM repository, and that snapshot is just a version of OPAM. So you can just view the world's OCaml code as one massive Git tree. There'll be version control. It's just that there's separate routes for each of the packages, and we occasionally take a subtree snapshot into OPAM repository to freeze it forever. And that subtree snapshot includes the metadata and the source code and any local patches that we add. So.
And then you can see back the one, the OPAM file which is in the repository, the one which is the snapshot, you can see back later.
Oh, yes, sorry, that's a big one. So what Thomas said was you can subsequently, without releasing a new library, fix the metadata. And that's quite painful at the moment. So for example, the Oasis is particularly bad that we have to rev about 1,000 packages to fix a future compatibility problem. For example, safe string results in lots of warnings. Hundreds of packages break because of warnings as errors. I'd love to just remove that feature from the compiler because it just breaks a ton of future work.
Just as them now.
Right. No, well, it's very important for development, right? It's just that, like C, you're not meant to use that in released compiler, in released packages, but people often do because build systems are so complicated. We're going to fix build systems. I'm optimistic. That was a future-looking statement.
Okay, so we'll look forward to it.